You can't index your way out of a bad schema. You can't throw hardware at a bad schema. A bad schema is a decision that compounds over time, getting more expensive to fix with every row you add. Let's talk about the three most common schema mistakes and how to avoid them. Schema design is the architectural blueprint of your database. Get it wrong early and you will spend years patching symptoms instead of fixing root causes. The three mistakes we see most often: number 1, using random UUIDs as primary keys leading to B-tree fragmentation. And number 2, making every column nullable, which causes semantic ambiguity plus optimizer headaches. Number 3, the entity attribute value pattern EAV, which is like turning a relational database into a key value store. Let us consider a customer story. An e-commerce platform used UUID v4 as the primary key for their products table. At 5 million rows, performance was fine. At 50 million rows, inserts were getting slower and slower. The B-tree index on the PK was massively fragmented because UUID v4 values are random. Every insert lands at a random position in the tree, causing constant page splits. They switched to UUID v7, which is time-ordered UUIDs, and saw a 40% improvement in insert throughput and a 25% reduction in index size after a re-index. So now in demo, let us see how UUID causes B-tree fragmentation. So create two tables, one with UUID v4 primary key and the other with a sequential big serial primary key. Insert 1 million rows into each table. Now compare the index sizes using PG underscore relation underscore size. So where UUID occupies 38 MB and big serial occupies 21 MB. Now let us also create another table with UUID v7. Check the index size after inserting 1 million rows into the table. So here after checking the index size, you can see that it is 30 MB. So which means with UUID v4, index is bloated and lookups are slower. With UUID v7, index is compact, lookups are efficient, similar to big serial. Lastly, in second example, we will see how the optimizer can't use index efficiently because the column is nullable. So we are creating a table employees nullable, and also we are creating another table named employees not nullable. So from the above two tables, we see that indexes can be used on nullable columns, but the optimizers sometimes avoid them due to uncertain statistics. Adding not null makes the column semantically stronger and helps the planner to trust the index. It tells about the EAV anti-pattern. In product attributes table, each row stores a single attribute of an entity. To answer a simple query, we need multiple scans and typecasting. In products table, in the other table where we created the table named products, each attribute has a dedicated column with proper types. Queries are straightforward and uses index effectively. Before your next create table, ask three questions. Am I using sequential friendly primary keys? Are my nulls intentional or lazy? Am I modeling actual relationships or just dumping key value pairs?